week we started talking about how we could take rational expressions and do some multiplication and division. What we're going to look at today is what are we going to do when we have to either add or subtract these rational expressions. But before we get into the algebraic expressions, the rational algebraic expressions, let's just go back in our time machine here and think back to, all right, well, what do I do when I'm adding and subtracting fractions in general? Well, you might remember, hopefully remember, that whenever we're going to add or subtract, we want to make sure that we get common denominators. Sometimes that's easier than others. For instance, in this first example, our common denominator is going to be 15. So the fastest way to get there is just take our two denominators, multiply them together. And then remember, from there, we just had to do some adjusting. So we had to think about, all right, I took 3 times 5 to get 15. So I have to take 1 times 5. Same deal here. I took it times 3. So I got to multiply 2 times 3. And so when I put those two together, I end up with 11/15. So to find that common denominator, we just multiply the two denominators together. Versus one like this, where we have a fifth plus 3/10, I could still multiply the two denominators together, but sometimes we may actually be able to use part of, or the whole thing of one of the denominators as my common denominator. In this instance, probably our best common denominator would be 10. Which means I have to multiply by 2 in the first fraction, but the second fraction would remain the same. So in this instance, I have 5/10. But like usual, we have to make sure we reduce. We have to make sure that we simplify. And in this case, I end up with 1/2. Now, all that may seem like it's kind of old hat and things you've done a lot in the past. But all those ideas are going to carry over to what we're going to do when we throw in some variables. So let's say I'm asked to do this. I'm going to take 2x over x minus 1, and I'm going to add to that 3 times x plus 5. Well, the goal starts out the same as usual. Since I'm adding these two, I want to try to get a common denominator. And one of the options for that was to take the two denominators and multiply them together. Now, I'm not going to literally multiply them out, but I'm going to write in x minus 1, the first denominator, times x plus 5. And then I have the same thing for the second fraction. All right, from there I try to look at how am I going to adjust things. So my original fraction had x minus 1 in the denominator. Now I have x minus 1 times x plus 5. So that means I have to multiply the numerator by that same x plus 5 term. Same deal for the second fraction, except this time I had to multiply by x minus 1 to make my adjustment. So I'll multiply the top by x minus 1. All right, now we have these common denominators. So my goal is to try to get everything together in the top that are actually common terms. So I'm going to multiply the 2x times the x plus 5, which gives me 2x squared plus 10x. I'm going to add to that the numerator of the second fraction. So once I multiply that out, that's 3x minus 3. And all of that is over this x minus 1 times x plus 5. Now on to the simplifying step. Part of the simplifying would be getting common terms together. So we got 2x squared plus 13x minus 3. And all that's over x minus 1 times x plus 5. Well, the only thing left would be now to see, could I factor the top? Because if I could factor the top, I could maybe do some simplifying. Maybe there's a way I could, in essence, reduce this fraction. Well, if I look at the top term here, I would have to take 2 times negative 3, or in other words, I have a goal of negative 6. when I multiplied. So if I thought about doing a generic rectangle, I'd be doing negative 6x squared. I'd want to multiply to get 13x, and I'd find out that that's not possible. So I actually have my simplified form here, because if I could not factor it, then I could not do any reducing or any simplifying. So backing up to our steps, we took the two denominators, multiplied them together to get our common denominator. Made our adjustments by figuring out, all right, what did I multiply to get to that new denominator, and doing that at the top. And then essentially from there, I just had to do some simplifying or putting those terms together. All right, let's look at another example. All right, this next example, I have x over 3x plus 1. And I'm going to add to that 2x squared minus 2 over x minus 5 times 3x plus 1. All right, first goal here, again, is to get a common denominator. Now, as I look through the terms, I've got the 3x plus 1 in the first denominator, and I also have the 3x plus 1 in the second denominator. So that tells me right away I definitely need 3x plus 1 as part of my common denominator. The other part I'm going to need now is the x minus 5. Now I start making my adjustments. Well, to get from 3x plus 1 to 3x plus 1 times x minus 5, we have to multiply by x minus 5. Over here, the denominator is actually the same, so the numerator is going to be the same. Now, some of you may be looking at that first fraction and saying, well, wait a second, I've got x minus 5 over x minus 5. That really simplifies to 1. The problem is I don't want to take that step here, because if I were to do that, I'd really be just right back to where I started. And that's not going to help me out, because I'm not going to be able to combine those together. So I don't necessarily want to do any simplifying at that step. I'm going to say my simplifying, in most cases at least, until the end. All right, let's try to put the two fractions together. So I'm going to multiply the x times the x minus 5, which gives me x squared minus 5x. I'm going to add to that, because we were supposed to do addition. 2x squared minus 2. All of that is over this 3x plus 1, x minus 5. So if I put that together, I've got this. I've got x squared plus 2x squared, so 3x squared. I got minus 5x, and then minus 2. And that's over 3x plus 1 times x minus 5. Well, just like any other fraction, we always want to check and see, could I possibly simplify that? Well, again, the only way I could really simplify it is if I could factor the numerator, because right now it's not in factored form. Well, if I look at this one, my goal would be multiplying to get negative 6, adding to get negative 5. Well, that is possible. So let's see what I could factor that 3x squared minus 5x minus 2, what I could factor that into. So I'm going to put this into my generic rectangle and see what I can come up with. So I got 3x squared and negative 2, which again means I need negative 6 when I multiply and negative 5 when I add. So that's going to give me negative 6 and 1. So that's what I'm going to put inside my empty boxes there. So if I look at 3x squared and x, they have an x in common. X times 3x would give me the 3x squared. X times 1 would give me x. And 3x times negative 6, or I'm sorry, times negative 2 would give me negative 6x. And always check it, -2 times 1 is -2, so it works out. So I could actually rewrite this as 3x plus 1 times x minus 2. All that's over the 3x plus 1 times x minus 5. Well, now that it's in factored form, I look and see, could I do any simplifying? And the 3x plus 1s actually simplify to a nice neat one. So my answer for this in simplified form would be x minus 2 over x minus 5. So just like you did way back when you learned fractions, back in whatever it was, 3rd grade, 4th grade, you always wanted to try to reduce the fraction as far as you could. In the end, that hasn't changed. We still want to try to simplify as far as we can. Keeping in mind, though, that we couldn't simplify unless I could get it into factored form. All right, why don't you guys try this? We got 9 minus 3x over x plus 3 times x minus 3. And we're going to add to that 2x over x plus 3. So why don't you pause the video, and why don't you try this problem? And after you've gotten your solution, go ahead and start the video back up, and you can check and see how you did. All right, let's see how you did on this one. First goal remains the same, getting common denominators. And in this case, we have the x plus 3's for sure. But we also have to include the x minus 3. So that meant the first fraction you didn't have to change, so it's still going to be 9 minus 3x. The second fraction we have to multiply by x minus 3, so 2x times x minus 3. So now we can put it together. So I've got 9 minus 3x plus 2x squared minus 6x. That's over the x plus 3 and the x minus 3. So if I put that together, I've got this. I've got 2x squared minus 9x plus 9. That's over x plus 3 times x minus 3. All right, again, we want to see, could I possibly factor the top, because that's the only way I can do any simplifying. So my goal right now would be the 2 times the 9, or 18 when I multiply, and -9 when I add. I think that one is possible. So let's see what we get when we factor it. So we have 2x squared and 9. 18 would be our goal for multiplication. -9 would be our goal for addition. So that means we can do -6 and -3. So I've got 2x squared and -6x, so 2x in common makes this x. 2x times -3 gives me -6x. X times -3 gives me -3x. -3 times -3 is 9, so it checks out. So the top can be factored into 2x minus 3 times x minus 3. That's over the x plus 3 times x minus 3. And so we could simplify this one a little bit. We get x minus 3 over itself. And so my answer for this one would be 2x minus 3 over x plus 3. So unfortunately, these take a little bit more time than what we did when we did multiplication and division, because we do have to get that common denominator. But then we also have to eventually check and see if we have any extra simplifying. Whereas when we did the multiplication division, we did a lot of the simplifying up front. All right, one last example that I want to look at with this. Let's say that I have these two things that, again, I'm going to try to add together. Notice this time when you look at the denominators, they're not nice, neat ones where it was easy to pick out how to get a common denominator. And in fact, both of these are in standard form. Neither one of them are in factored form. So it's going to make it a little bit easier on us if we can look at those denominators and try to figure out, well, could I maybe factor those? Because if I can factor them, I might have a little bit better terms to work with. So let's look at the first denominator, the 3x squared plus 13x plus 4. And what we're going to do is we're going to see, could I maybe factor that? Well, my goal would be getting 12x squared when I multiply, 13x when I add. So this one we could factor. We can do 12 and 1. So I'm going to enter those in to my missing box instead. Well, 3x squared and 12x have a 3x in common. 3x times x gives me 3x squared. 3x times 4 gives me 12x. X times 1 gives me x. So that first fraction, we can actually rewrite the denominator as 3x plus 1 times x plus 4. So I'm going to do that. I'm going to rewrite down here 3x plus 1, x plus 4. And we already knew the numerator was 2x minus 1. All right. Now we're going to move on to the second fraction. Same deal though, we're going to check the denominator and see if we can factor it. Well, I'd be trying to multiply in this case to get negative 28, add to get negative 3. Well, I can do that as well because I can do x minus 7 and x plus 4. So we're going to change this fraction and make that our denominator. So I've got x minus 7 and x plus 4. The original numerator was x plus 3. All right, so a little extra work there because we had to factor those denominators before we did anything else. Now we're back to what we have been doing. Is there a common denominator I can come up with that will allow me to add these two fractions together? All right, well, when I look at those two denominators, the first thing I notice is they both have x plus 4s. So I know for sure that I'm including x plus 4. After that, I'm just including any other terms that at least one of them has. So we had 3x plus 1 in the first one, so I got to make sure I include 3x plus 1. We had x minus 7 in the second one, so I need to make sure we include x minus 7. Now we make our adjustments. Well, in this first fraction, we had 3x plus 1 and x plus 4, so we had to multiply by x minus 7. So now I have to take eventually 2x minus 1 times x minus 7. I go to the second one, and the difference between those two denominators was multiplying by 3x plus 1. So I got x plus 3 times 3x plus 1. All right, now we're to the simplifying step. Well, I can't really simplify until I multiply things out. So I'm going to multiply that first numerator out. If I do that, I'm going to have 2x squared. I'm going to have negative x and negative 14, so negative 15x. And I'm going to have negative 1 times 7. Sorry, negative 1 times negative 7. The second fraction, I'm going to have x times 3x, 3x squared. I'm going to have 3x times x, so 9x, and then another x, so 10x. And I got 3 times 1, so 3. All that's over that common denominator. Now I put stuff together. So I've got 2x squared and 3x squared. I've got negative 15x and 10x. And I've got 7 and 3. All right, been on this problem for a while, but we're still not quite done because remember we were going to look and see, could I possibly factor it? And if I can factor it, does that help me simplify? Well, the numerator all have 5 in common, so I'm going to pull that 5 out. And now I'm going to see, could I multiply to get 2 and add to get negative 1? Well, in this case, I can't do that. So even though I could factor, I don't always, or I'm not always able to simplify it. So just being able to factor doesn't guarantee that I can simplify it. So I finally have my answer here. And you could have kept it in this form here, but either one of those would be acceptable. Honestly, a problem like this is probably about as tough as you're going to see. One where you'd have to factor both denominators to start. You'd have to then find a common denominator. There was a lot of terms that you had to multiply out. But finally, we could get to that simplified form. Now, all the problems I did were addition. As far as process is concerned, subtraction would be the exact same thing. You've got to find your common denominators. You've got to combine terms together, and then you have to do some simplifying there. So to me, this is the tougher of the two. Multiplication division is a little more straightforward than addition and subtraction. So this will just take some practice, and we'll practice this, get more comfortable with it as we go along. This is not something you'll have to worry about for your quiz today, but this is kind of an introduction to some things that we'll be doing as we finish chapter 3.